Sir, left of 87.
Sir, to the
Left
left
of
of it.
87. So please tell me, I am getting two output. Left of 87, one people have said left of 99. There are two sort of answers available to me.
Between 82 and 87.
Between 82 and 87. That means whether the 82 will be the parent of the 85. Am I right, Dipesh?
Yes, sir.
And if it is a parent, every node has a two pointer, left and right, where it will be get placed.
Left.
Left. So
Left
let's see.
87.
Left of 87. Sir.
Left of 99.
Still so many confusion, so many predictions. So first we need to understand how this value will be get arranged. Once again, I am revisiting. Values are get arranged, of course, in context of parent node, of context of root node. First, it will start its traversal from here. Whatever the value I am inserting, say for example, I am inserting 84. So first it will come over here. What is the value of root? It is 60. Correct? So if it is 60, then it will first take a decision. I will go left hand side or right hand side. So if the value is 84 is less than 60, then it should move towards the left hand side. If the value of new node is greater than root, then it should move towards the right hand side. So from here, the first level scenario that I will found over here, the value is greater than 60. So it should be available in the right hand side of the root. Am I clear? Now it will check, is my right hand side having any value? Is it null or not null? Once again, I am reiterating. So if it is not null, then it will go and traverse the next link. That is coming as 75. Once again, it will go and check the value which I want to insert. That is 84 is greater than 75 or not, or less than 75 or not. If it is greater than 85, 74, the 75, which is the current node in the right hand side, then it will once again go and check what my newly inserted value should be available right hand side of this node. Does my right hand side having any value? Is it having any null or not? If it is not, then once again it will revisit that next. So it will find 82. Once again 82 and 84 is being compared. My newly inserted value is greater than the current node. So in that case, it is surety, okay, fine. I need to place that value right hand side anyway of the 82. So I need to check, is right hand side is having any value? Yes, it is having any value. So it will go and visit that link. Now it is coming 87. Once again, 87 is greater than 84, which I am supposed to insert. So now it will thought, okay, the newly inserted value is less than the current node. So I need to place it in the left hand side of my current node. But is my left hand side of 87 is having any value? Yes, no. If it is yes, then I need to go and revisit that. So I will be over here now. in a position 85. Still 84 is less than 85. Am I right? So now it will go and search. 84 is the newly inserted value. I am at present in 85. As any point of time, if any value that I need to insert which is less than of my parent, I must place it into my left hand side of my parent. So I will go and place 84 over here, left hand side of 85. So let's go for a insertion. So I will say insert. See how the traversal are happening. So I hope everything is clear now. How the value will be get arranged.
Yes.
Is there any confusion? Please ask me. Or you can tell me, suppose if I am going to insert 52 in this list, where it should be get placed, in which, who will be its parent, number one. And if whatever may be the parent node, under which, in which pointer, left or right, it will be get placed. My value, new value is 52. Think and explain me.
Right of 49.
55.
Right of 49.
Right of 49. It should not be right of 55. Am I right?
Left of 55.
Right of 49.
55, sir.
Left of 55.
Left of 55, sir.
But not a 52 is a 55 actually. There's going to 60 to 55.
So first it will check with the root 60 greater. 60 is greater, so it should placed in the left hand side. Then it will jump into the left hand side. It will find 55, which is greater than the newly inserted value. And if it is greater than newly inserted value, then I should look for the left hand side or right hand side pointer.
Left hand side.
So what is there inside of the left of 55? Already it is having null or not null.
Null.
49.
49.
Left hand side is 49. It is not null. It is my right. Think from your side, not from my side. Think from your side. Who will be your right? This will be your right. This will be your left. 55 is greater than 52. So if it is greater than 52, so my node should be appear in its left hand side. So in my left hand side already I am having a node that is 49. But 49 is less than 52. So value will be go into the right hand side of 52. So am I clear now? Everybody has any sort of confusion regarding placing the values? No means confusion has. Yes means confusion. What is that? You don't have confusions, right? Okay, fantastic. Now see, maybe whatever may be my nodes, whatever may be the arrangement of nodes. Now we are going to apply a delete operation. So delete operation means removing the node. Maybe I want to remove this, maybe I want to remove this, maybe I want to remove this, or maybe I want to remove this. The first and foremost thing that comes with your removing the value, okay, after I may have any choice to remove values. from existing B tree. Correct? But when any remove operation happens, I must ensure that my current tree should not be disturbed. That means there must be an arrangement that going to be happen in between this node in such a manner so that whatever value will be removed, they will be get removed, but rest of the tree should be intact in terms of their communication, in terms of their parent-child relationships. I must not, suppose this link will be, suppose this particular node will be get deleted, then what will happen? I need to think about its child, because this node is having its left hand side or right hand side, so many other nodes. Maybe up to this everything will be intact. And if I am going to remove this, try to understand what I am saying. I am trying to delete this particular node. And if I will try to delete this node, there should not be any disturbance happens for this. They should be intact inside of the tree. This connection should not be this edge, rather than critical word I should use in terms of binary tree. The communication between the nodes are known as edge. So edge should not be disconnected. My rest of the child should be intact over here. Disconnected from the tree because of I am deleting this. So first and foremost thing, whenever I am deleting any node, it should not disturb the communication between the other nodes. They should be intact. But if I need to make them intact, once again question arises, what will be happen if I will delete this 87 for these nodes? 84, 85, 89, and so on. How they will be arranged over here? Because this is the basic challenge of binary tree. So in binary tree, whenever deletion happens, first and foremost thing I need to understand, I need to make a rearrangement between the nodes, which is already over there after deletion. So after deletion, who will be parent of this node? I need to take a decision and I need to make it available. Now question arises, if I am deleting this node, say for example this node, it does not make any effect in my rest of the tree, because rest of the tree are intact, because it is a what kind of node? Anybody can tell me? It is a leaf node. It is the lastmost node within the tree. So if anybody will delete this particular node, I don't have any effect on the rest of the tree. Am I right? Because it is the lastmost tree. If someone from the last level have been deleted, so rest of the things will be intact. But whenever I am going to delete this kind of node, I need to think, because it has multiple children, just like anybody within a family, a great family head will be died. So what will we usually says in a neighborhood? Okay, his father had died. Who will look after his child? So same thing I need to do over here. I need to keep some set of arrangement for their child before I will die. Are you understanding what concept I want to define in front of you? Anywhere, anything. Why I am saying ki if I will delete this node, I don't need to think, or I don't need to bother about the last other nodes. But whenever I need to delete this node, or whenever I need to delete this node, or whenever I need to delete this node, always I need to create an arrangement. Why? Because these are the node and nothing but a subtree, which is containing more some set of child with them. Or if anybody will want to delete the root. So in a dynasty, if one king will be died, what will be the next arrangement of the dynasty happens? From the history level, what you have seen? I am not getting any response. Either you are not able to understand, or if you are having any question, please ask me. I will repeat
His
it.
son will take his position.
So his son will take his position, Jubraj, if I am not wrong. Right? So I need to take that kind of arrangement also over here. So if it is going to be deleted, who are its son? This is one son, this is another son, this is another grandson. What you can say?
89, sir.
So I need to arrange something so that my existing flow of the list, existing flow of the tree should not get affected after the removal of this node. So now we people will just go with I am just removing all of my drawing. I will just go with the first level of observation. How delete operation, delete a node. Just think.
So we can
Delete a node which is a leaf node itself. Tell me.
so then we will
To delete any of the node from here which become a leaf node over here. First tell me what value I need to delete for in context of deleting a leaf node. Any of the value you can give
so
me.
if we are trying to delete 87, then we can
No,
compare.
no, I am not asking any questions. First, I need to say, okay, over here, see over here, there is a delete operation. I need to decide a leaf node to be deleted. You give me a value of a leaf node from this existing tree and observe the animation. That is my first task. So,
52.
anybody can, huh? Sorry, 42.
52.
52. Where it is 52? Let me check. This is. After this, there will be no node, so I can say this is a leaf. Correct? So, how? Please look into the animation process. I want to delete. That means I am first inserting a value. What value I want to delete? And that is a leaf node over here. So, after that node, there will be no other existence of any node over there. Delete. My rest of the node will be intact. Am I right? Previously, what was there? Previously, what was there? They are quite intact. Sorry. I need to once again create it. Oh. Quickly create this. 60, 52, 45. Uh, 48. $75, $83,
Sir, 55.
$55. Okay. First, you tell me where 55 will be getting inserted. Right to 48. Okay.
Yes, sir, 48.
Right to 52, na? It is greater than 52. So
Yes, sir.
automatically right hand side is null.
Yes, sir.
So it will be get added. Now, let's see. Let's take this particular binary. So I am saying I am going to delete a node called 83. So in this case, if 83 will be get deleted, hardly this particular connection will be anywhere is getting disturbed, right? That is the thing I want to say over here. Whenever we are deleting any of the nodes, which are leaf node of the binary tree. So if I will delete 48, for example, so if 48 will be get deleted, the rest of the connection will be intact because there is no hamper or in its positional level. So I will delete it. It will traverse. It will delete. Same. But whenever I am going to delete 52 or 75, there will be a problem. Because these nodes are having their children. So first level that is coming over here, delete a node which it's a leaf node itself, will not make any effect in existing tree. Are you agree with me? Leaf node, patla, those node which are not having any children. And if I will delete them, if I will delete 83, if I will delete 55, if I will delete 45, these all nodes are known as leaf node. They do not have their children, so there is no arrangement of any node need to be done in my existing list. But problem arises when if I need to delete a node which is parent of any other node. In other words, I can say I need to delete a node which may have one children. These are the two probabilities, or which may have two children. Whenever I am going to delete a node from my binary tree, my arrangement of the existing node I need to prepare in two set of cases, which may have one child, which may have two children. For example, can you give me an example from this tree? Which node I am talking having a one child? Sorry? 75.
75,
Right.
sir.
75, which is having either right or left any one children. So I am finding in its right hand side, there is 83 is a children. Right? And any node which you can identify from here, which is having two children,
52.
52, sir.
52, 60,
60.
because root is also there, no? Root is also a node. Correct?
Yes.
So please look minutely how the arrangement will happen when I am going with one children. That means I am going to delete this 75. What will the next arrangement of the node? Identify the scenario. Or whenever I am going to delete, suppose 52 or 60, any one of them, what will be the next arrangement of the value? Please, first you take a screenshot of this picture and then I will arrive with a delete operation. And your observation is required. For example, I am going with the toughest one. Toughest one means I am going with this, which is having two set of children, 45, 55. So 60 is linked with 52. 52 is linked in its left hand side with 45. In right hand side in 55. That means I can say 52 has two particular pointers or address value. It is in left pointer, it is keeping the value of 45. In its right pointer, it is keeping the value of 55. I am going to mark this node for delete purposes. So who or how my arrangement of the node is going to be effect after deletion, that you need to observe and give me the logic, nothing more. I'm not asking any programming things. Who or how the rest of the children, which is having by 52, is going to be arranged. First you see, then you give me the answer, what actually happens.
Sir, from my understanding, if we are deleting 52, then we should compare both the child element and whichever is the highest, we should make it the root element.
Sure. Let's see. Let's see. Don't give any particular prediction. Rather than, we have all with me. My animation is ready. So I am going to delete 55. So, sorry, 52. And after deletion of this node, who will be your parent of 45 or 55? That I need to decide.
55.
Let's see. Once again, I am going to insert some 43. I hope you people have seen this screen. 45 have been up or rearranged, which is the out of these two children, which is one of them left hand side children. And it is become now parent, and the rest of the field will as it is in its own position. So in other words, I can say I have deleted 52. The address of right pointer of 52 is given to 45. So 55 is now getting pointed by 8. Once again, I am inserting 43. So it is now my left and right both. and I am going to delete this 45. Delete. I am going to insert 41. I want to delete. I am going to also insert 40. Now I am deleting 43. So now 43 is not only has children, but also having a grandchild. Now come to this. I am going to delete 43. This one. So what observation you have found from this 3 set of delete operation I have shown you? A delete a node which is having multiple child. Once again, I am going to give you another example. I am going to delete 41. So if you remember the picture previously, if it is there in your mind, who will be the next node after 60? Tell me.
40.
Are you sure?
Yes,
So
sir.
let me see. That means I can say you have a good observation. Now, what is the logic?
Leftmost.
Left child become the parent.
Yes.
All of you are agree with Adesh and others. Left node becomes the parent.
Yes, sir.
Any other logic you can apply? Other than left node, anything you need comes in your mind quickly. Other than left.
Left.
You are right.
Value less than the node.
Sorry, I cannot hear you properly. Very good. The node, children node. In between the children node, whoever may be the minimum value is going to be treated as a parent. So if I want to delete 60, it will compare what are the children node of who is lesser. Of course, lesser will be always in the left hand side, according to the rule. And that will be always being come as a top. So let me check once again, do these things. So what I need to delete? I need to delete the root node itself over here. 60. 60 has having 2 children, 40 and 75. Rule says who will be the minimum value that will become your parent. So 75 parent become or 55 parent become whom? By whom? By your this. But root case, it is something else. It is taking lowest value always in between the period. Now let me give some insert, new value. Say 31. Say 43. Now I want to delete 40. So in between this subtree, who is the lowest value? 31. So 31 should be shifted over here. Now let's do something in my right hand side because everything I am showing you from your left hand side. Let's insert 80. Let's insert 89. Now in this right hand side scenario, 83 having 2 children. I want to delete 83. So if the same logic is there, so after 83, it starts searching which is the lowest value. And that will be get posted as a parent. Is this logic clear to you? Is this arrangement is clear to you? Now I will come back. If you are clear with this, then I will come to the code. Before that, I am not going to the code.
Can you explain the root one?
After root, which is the lowest one? Now see. Tell me after root, which is the lowest value is having? I am having
41.
43.
53. Where is
43. 43.
1.
So I want to delete root. 55 is my root. So in this case, what will happen?
43.
43 will become root now.
31 become root.
In terms of root, actually what happening? It will start searching from its left hand side continuously and find the leaf node over there. Where is my last leaf node is coming? Just take example once again for this root, but actually I don't want to really discuss the root anymore. However, when comes discussion came, I will go with it. Say I am having 31, I am having 25. I am having 24. I am having 26. Take all the possible process. Now I want to delete 43. Look into the animation, how it is traversing and what it will take. It will depend always. Root level node deletion is another concept. But now I am always, it is going to take the lowest value and the root has two nodes, which is lowest among them will be checked. Root has two nodes, out of which if I am going to delete 31, so it will always need to search. Don't need to go with a root now. First, you need to identify only two scenarios. What I am saying. I will come back with the root. Don't worry. I will come back. Root is supposed to be balancing the process. Enter thing. There is a particular another concept. But I have at present. I will just go with these two scenarios. I want to delete a leaf node, and in terms of delete a leaf node, there will be no concern in the existing list. And there are two options. I need to delete a node which may have a single children, either right or left, or may have two children. So in this case, whatever may be the child I am having, that become parent. So if I need to delete this particular 89, which is a leaf node, hardly there will be any effect in this list. But if I need to delete 80, whoever may be a child, it will placed in place of 80. So now 75 previously pointing to 80, it becomes 75 need to point to the 80 anymore, 89 anymore, and 80 will be removed. So if there is a single child, either left or right, so that single child becomes the parent. No problem. But when there is two children, out of these two children, who will be the lowest will be taken as your parent. So if I have 24 having two children, or say 89 having two children, let's see. 89 having a two children, like whenever I am talking about, suppose 82. So it becomes left hand side of 89. It is the left children. And if it is having another child called 95, so it 89 having now two set of children. So in between this 89, if I need to delete 89, it will go and search who is the lowest level. So if I need to delete 89, it will just push up 82 over here. That means minimum node value of the existing parent node is going to be added as a parent. So in other words, I can say previously 80 in its right pointer holding the 89's address. Now 80 is holding the address of 82. And 89's right hand side address will be given to 82. Two changes. So if I need to draw this scenario once again, suppose I am having 81. I am now drawing the things. What actually happening? Whenever I need to delete a node, that node is having two set of children with me. I am going to draw this. So just I am not coming from root level. I am just coming over here. Just think what is happening. Everybody, I am writing over here the memory address. Don't confuse. This node is having a memory address called 85. It is address, not its value. Value will be written inside of it. So take care of that. This node is having a memory address, say 121. This node is having a memory address, say 52. And this node is having a memory address, say 45. Think it from here, this level. This is my 80. Okay. 80 will be pushed over here. Now think about this node. 80 is having $82 as its child, but in which pointer it is having? in its right hand side it is having, because it is greater than 80. So I am talking about this node. So this node is containing a value called 82. Now 82 is having two set of child. One is in its left hand side, one is in its right hand side. So 81 is actually having by 8. So I am coming over here. 81. Now I am going with another value, that is, it is 95. So these are the value arrangement thing. Okay. Now, in my this node, that means I am talking about this node, which is having a right child, and right child holding the address of this node. So I can say actually my communication happens over here. So in this particular area, I am having a value 1 to 1. Agree with me? Yes, no.
Yes.
Anywhere, any possible problem, you ask me without any hesitation. Are you agree? 121 is the memory address of 82, and it is greater than 82. It's in right hand side. 121 will be placed. Now 82 is actually pointing to whom? 82 actually pointing to two children. One is this, one is this. So in its left hand side, what is the memory address will arrive? You please tell me over here in the left hand side. Which memory address will be arrived between 52 and 45? My question to you, I am asking. 52.
52.
So left hand side is pointing to the lowest value. And over here, which memory address will be arrived? 45. Right hand side is holding the right side value. Correct. Now my delete operation is going to be happen over here. So I want to delete a node which is having two set of children with them. These two value are null. This is null, this is null, these are lift node. And this is my parent node which I need to delete. In its left hand side, the address of 52 available. In its right hand side, the address of 45 is available. Now, what rules you have defined over here? If I need to delete any of the node which is having two set of children with it, I need to compare who is the lowest value between these children. So I need to make 81 over here. So this value need to be replaced over here. This is the rule that we have seen. Yes, no. So please come along with me. Think.
Yes, sir.
Clear? So if I need to place this 81 over here, what are the necessary changes I need to do in context of 80? What is my target? I need to delete this. In order to find that delete this, I need to find who are its child. I found 81 and 95 is the child. Who will be king? 81 will be king. So 81 will be pushed over here, 82 automatically get relieved. How this thing will be happens in context to this? It's parent node. First tell me, 80 is holding the address of one, whom? 80 is holding the address of whom? Deleted node. 82. That means 121. It is holding. Now I want this 80, instead of 82, this node will be replaced. So what I need to do? In other words, I do no more want to do point this. Now I want to point this. How I will go and do? I need to keep the address of 52 over here. If I will place a value over here as 52, which is the memory address of 81, what will happen? This connection will be disconnected, new connection will be created, and it will be over here. Am I right? Yes, no.
Yes, sir.
We are just swapping the memory address. Previously, 80 is holding the memory address of 82 in its right hand side. Now I am saying whatever the deleted node, whatever the left pointer address is, I am passing over here. So what will happen? It is going to point now this memory address. And if it is going to point this memory address, connection between this and this will be removed. So now it becomes this. But still, this delete node is holding the 95. Now I will arrange from 81 level, 80 level, now I am pointing over here. But still this pointing is active over here. This edge will be get deleted. I don't have this. This is no more over there. Now, if I will say delete node has right pointer 45, that I am going to place over here in its right hand side. What will happen? 45 will be added over here. Now there is a new connection will be created from this point towards this. And this will be removed. This will be automatically removed. So in simplest manner, if I will discuss, step by step, if I will discuss, first, node to be deleted. Whose? Left pointer address to be shifted to its parent. Step 1 is coming with this. This node code, whichever the node I want to delete, whose left pointer address, that means 52, I will shift it into its parent, that is 80. And in its parent, write memory address, because always this value will be greater than this. So it will be placed over here. So new connectivity created with this. Second, RPTR, that is the right pointer of deleted node. Given to the RPTR of smallest child. That means address of RPTR of deleted node, that is 45, is given to the smallest child RPTR. Thing is we are going to handle in compare of child. So a node which is having two set of child, first I need to find if these two set of child are specifically the node which is lowest one. So I select that. That could be the parent now. So 80 is now going to point this. So if 80 need to point this, it is RPTR, yani right hand side PTR will take the left hand PTR of the deleted. So this value will be get connected with this, and this value will be get connected with this. This is the solution that we are getting from. And automatically, because this connection will be disconnected, this connection will be disconnected, automatically now this will be a discrete node from here. So this is the arrangement that is basically we need to do. Only I need to swap the position. Which position? First point, my parent node of deleted node get the address of the smallest value. So now parent node pointing to this. Now my deleted node's right pointer value is given to the right pointer of the smallest node. And automatically it will create this connection. It will be displayed. So this is the thing that we are going to handle from this particular scenario. So I have two set of cases with me. One case, if I want to delete any leaf node directly, I will just remove. There will be hardly any problem. If I need to delete any of the node which is having a children, children become the parent. One child. And if any node having two child, the smallest value become the parent. These are the three concepts that we are taking over. So anywhere, please analyze first by yourself. I am coming to the code. First you understand this scenario. You can take this particular, I can say URL at your machine. I am giving you 10 minutes of time. You create your own memory addresses, check those values. In this particular site, I am copying it and putting it in my chat and giving you 10 minutes of time to analyze the same thing that I have discussed. Even if I haven't discussed any code, I have discussed three things to you. First, if any leaf node to be deleted, it can be, does not affect any of my current structure of my tree. If I need to delete a node which is having one child, so child become your parent or place of your deleted node. or if your deleted node has two child, in that case, I need to think who will be the lowest one, we will given the particular part in place of deleted. These are the three cases I have discussed. So please check that scenario. This is a wonderful site. You can also get it. And you apply it, analyze it, and after 10 minutes, I will start with the code. Code is having 110 lines. Because already those lines I have discussed. Quickly, and give me output after 10, where you are stuck in, where you are not understanding. Then only I will go with the code, not before that.